The sun looks calm. Then it hurls a billion tons of plasma into space. When one of those blasts heads our way, it can bend Earth's magnetic field and light the sky with aurora. How does that work? How bad can it get? And what can we do about it? Give me a few minutes and you will be the calm voice when the next solar storm headline hits. The sun is not a solid ball. It is a sea of plasma. That means atoms are stripped into charged particles that flow like a hot electric ocean. Moving charges make magnetic fields. Magnetic fields push those charges back. The sun runs on this feedback loop, a magnetic dynamo that stores energy and leaks it into the solar system as a steady solar wind. Most days that wind is a breeze. Some days the magnetic field gets twisted into tight knots. Knots store energy. Knots snap. When a knot snaps, two very different things can happen. One hits at the speed of light. The other arrives like a freight train. A solar flare is a flash of radiation from the snap. X-rays and ultraviolet light flood outward almost instantly. They can disturb radio signals and energize particles. A coronal mass ejection, or CME, is different. It is a magnetic cloud full of plasma that gets launched into space. Think of it as a cannonball with its own magnetic field. Flares are the flash, CMEs are the punch. Here's why that matters for Earth. The flash hits first. The punch decides how rough it gets. Earth has two shields. The atmosphere soaks up the high-energy photons high above us. The magnetosphere guides charged particles away from most latitudes and funnels them toward the poles. When those particles rain into the upper air, they make the gases glow. That glow is aurora. So most solar storms are not dangerous for people on the ground. They are a light show. The real risk is not to people. It is to machines. Satellites can get charged and glitch. GPS and radio links can fade. Astronauts need shelter. Long flights near the poles sometimes reroute. On Earth, the big worry is the power grid. A CME carries a changing magnetic field. Changing magnetic fields can induce currents in long conductors. Our grid is one giant network of long conductors. Extra current can trip protection systems or stress transformers. We have seen this before. In 1989, a strong storm knocked out power across parts of Quebec for hours. In 1859, the Carrington Event made aurora so bright, people read newspapers at night, and it zapped telegraph lines. So, is a modern repeat a civilization reset? Short answer, no. Long answer, prepare, and it is a speed bump. Do nothing, and it is a long week. Here's the usual playbook. First, you see a flare on solar monitors. That is the flash. Minutes to hours later, fast particles can arrive and bother high-frequency radio. Then, the CME shows up after travel time, often between about 15 hours and a few days. When it hits, Earth's magnetic field compresses. If the CME's magnetic field is oriented the wrong way, it can connect with ours and dump more energy in. The tail of our magnetic field stretches, then snaps back and releases energy toward Earth. That is a geomagnetic storm. You will hear about bright aurora and occasional outages. Most pass with minor issues. A few are strong enough to be memorable. We have even had a near miss. In 2012, a Carrington-class CME crossed Earth's orbit just after we moved past that spot. There is debate about worst-case damage. Some studies model heavy transformer loss and long replacement times. Others find that modern protection helps. Both agree on the fix. Know a storm is coming and reconfigure the grid. That can mean temporarily taking some equipment offline, redistributing load, and watching regional weak spots. Compared to earthquakes or hurricanes, upgrades to ride out space weather are cheap. This is not about fear. It is about lead time. We track the sun from many spacecraft and ground observatories. We can see an eruption form and forecast its path. We even park spacecraft upstream of Earth to sample the solar wind before it hits us. That gives operators tens of minutes to a few hours to act. Airlines can reroute, satellites can switch modes, grid operators can open extra lines or reduce stress. households do not need to panic. If a truly severe warning goes out, charge devices, keep a flashlight ready, and expect a great night for aurora. So, what should you actually remember after the next scary headline? Flares are the flash. CMEs are the punch. Aurora means the shields are working. People on the ground are safe. Machines need attention. With early alerts and smart grid actions, even big storms become manageable. The sun will send another monster our way one day. If we prepare, it will be a story, not a catastrophe.